Hello friends, I am Dan Delamarski, and today we're going to be doing what Vin Diesel does best, and that is look under the hood.
Hey, pop the hood.
Pop the hood?
Pop the hood.
Of Spec Kit. Probably looking under the hood of Spec Kit is not as exciting as looking under the hood of a supercar, but nonetheless, we're going to be doing a deep dive into Spec Kit right now. So, what is Spec Kit? And if it's the first time you're hearing about this word, or words, or a project name, Spec Kit is something that recently we launched with our friends at GitHub, and it is essentially a toolkit to help you get started with spec-driven development. That is where specs are at the forefront of your development process. You're not focusing just on code, but are actually using specifications to tell AI agents or coding agents or engineering agents, whatever you want to call it, what to build and how to build it. So Spec Kit is this nice way here of managing that workflow, right? So Spec Kit basically comes in two different pieces. We have a CLI, a command line interface that you can use to bootstrap the scaffolding for your spec-driven project. And there are some templates. So templates are available here as releases. You can just download them, and we'll get to that in a second. But also, if you go to github.com/github/spec-kit, you'll get the README that allows you to get started, and you'll see everything right here in one place. Very convenient just for you, our developers. So, Spec-Driven Development, you can read more about this as well. It's essentially a pattern by which, as I mentioned, you are abstracting out a lot of the implementation details from the design of how those details should actually be built by coding agents. That's an important distinction here because oftentimes what we've noticed is folks focus so much on vibe coding where they just prompt the LLM to do certain things and they keep iterating it, but that's hard to reproduce, right? Like if you would share your work with your team, your organization, how would you do that? Are you just going to share your chat history? Probably not. So specs come to the rescue. But instead of me just talking about spec-driven development theory here, let's take a look at what Spec Kit actually is. I mentioned that it's a CLI and templates. And let's take a look at first at the CLI. The CLI is a bootstrapper for templates. That's all it does. There's no super magic there. It's just a tool to basically bring in the templates from the repository locally in your project. It's located in SRC, specify CLI. Of course, it's free. It's open source. It doesn't require a subscription or paying anything. You just download it. And most importantly, it works across agents. So if you're using Copilot or Claude Code or Gemini CLI or even Cursor, yes, that is right. I said Cursor, you get it to work. Things will just work because it's an experimental set of patterns and practices that is just bundled up in a nice consumable package. So if you're curious about the source code for the CLI, go to the SRC folder. There's a specify CLI and there's a init file, and you can browse through it and see exactly what the CLI is about. And if you spot a bug or an issue or have a feature request, this is the world that lives. Now, I also talked about templates. So for that, we're going to go here to the repo root, and I'm going to look at the Spec Kit templates in my releases. We support different agents. As I said, we support Copilot, Claude Code, Gemini, and Cursor for now, with more agents coming in the future. But for every single agent, we have a specific bundle that contains the templates and agent-specific prompt files that are generated from the templates that exist in the repository. We'll see that in action in just a little bit, but to give you an idea of what every release or what every bundle contains, let's download here a Spec Kit template for Claude using PowerShell. So, important distinction here because as we support multi-agents, we also support multiple platforms. And on some platforms, you have PowerShell. On some platforms, you have Bash. And how do you know which to run? Well, you're going to have the right bundle for that. So let's take a look at what's inside the zip file here for my Spec Kit template for Claude and PS. We have the .claude folder, right, that contains the commands, which is plan, specify, and task. These are the standard commands that are made available through the specify CLI, and it's embedded into whatever agent you're using. It's /commands. /commands are not really new. And there's a .specify folder that contains some metadata related specifically to Spec Kit, and it's bootstrapped also by the specify CLI. And we have some memory stuff where it's a constitution document, and we'll get to the constitution in just a second. There's some helper scripts, and because we're using PowerShell, we only have PowerShell here. So I can just open here, and there's some of these helper scripts and templates that are used to bootstrap my spec, my plan, and the tasks that you've seen in the video that I've hosted just the other day. So this is the version for Spec Kit template Claude for PowerShell. But let's say that I'm downloading Copilot with shell scripts. All right, so maybe I'm running this on Linux or Mac OS or some other system. I'm going to save this. Let's open it. And you'll notice that now instead of the .claude folder, I have a .github because GitHub Copilot, that's what it expects. It expects me to have a .github folder that contains prompts. And the prompts are named appropriately for Copilot to recognize that these are slash commands, right? They're slightly different than Claude. And I hope that in the future, all this is going to be consistent, but it's not for now. So that's why we need this kind of special dance around the bundles to making custom. And specify is consistent across the board. So we have the memory scripts and templates that I just showed you, but the scripts in this case are bash scripts. They're shell scripts that I can use on my Linux or Mac OS system, or maybe even on Windows with WSL2. So when the CLI is acting, when I use the specify CLI, all it does is just downloads these zip files here. But let's see the CLI in action. So I'm just going to go here to my repo root. I'm going to scroll to the README file. I'm going to copy this command, right? So we have this command. It's a little bit ugly because I haven't published it to PyPI yet, but it's coming. I will get to it once we fix some of the initial exploration. So I'm just going to copy this, go to my terminal, and paste. So I can initialize a project. So I'm going to substitute the project name with something that I want. And in this case, we're going to build a podcast landing page because this is the easiest demo for me to show you and not take 3 hours. So I'm going to call it SuperPod. Right? So when I trigger this, the actual CLI is being downloaded from GitHub. It's a very ugly way to do this. I have this git HTTPS, the repo. Once this becomes an actual package on PyPI, it's going to be much more smooth of an experience. But for now, it is what it is. So we have the specify experience here. It's kind of nice. It's a console terminal app, but I can actually use my keyboard. As I mentioned in the previous video, you should be comfortable with the keyboard. You should be using the keyboard. So I can use the up and down arrows to select my agent of choice, and more agents are coming, right? That's what I said. So you can hold me to my word. I'm going to use Copilot. So I'm going to press enter here. And now I'm being prompted to select the script type that I'm using, shell or PowerShell. It defaulted to PowerShell because I'm running this in the context of a Windows operating system, and that's where PowerShell is. But you can still use PowerShell core on Linux. You can still use shell scripts on Windows. So we give you the option. You can choose what you want. The cool thing about the specify CLI is that you don't actually need to use the interactive approach. So here I'm showing you, like, I'm clicking on the keyboard, I'm kind of tinkering with parameters and so on and so forth, but it's not really needed. It's not necessary. And that is because I can use the arguments that are baked into the CLI that allow me to have that flexibility of not having to press any key buttons. So I'm just going to go back to here to my repo. And by the way, the original video that I talked about is linked here. Click on it. Watch it. It'll give you a pretty good idea of what Spec Kit does. But there's also a section for specify CLI reference, and you can use this as a reference point for how to use the CLI, and including things like the non-interactive mode. So I can use the --AI and --script parameters to just tell it directly what AI tool and what script language I'm going to be using. And I'm going to do just that, just to show you that it works. So I'm going to use AI, and then I'm going to use Copilot, and then script. I'm going to use PS because I'm running this with PowerShell, right? So we're going to do this, and let's see what happens. Boom. Project is bootstrapped. So now I have the project here. It's all set up for me. I have my SuperPod. It gives me, because I use GitHub Copilot, it gives me guidance to open in Visual Studio Code, and I can use these slash commands, right? Like, these are the slash commands that I've talked about in the previous video. These are the slash commands that you probably know about from other agents, but it simplifies the workflow because I can just use these to perform tasks for me, and we'll get to that in a second. And you'll also notice that there's some status reporting on the tasks that the CLI did. And like I said, there's no magic here. It literally, what it does, it just pulls the repository content, the release, the latest release, and just embeds it in the directory that you set it up. It can work for existing projects. It can work for a new project. In my case, I'm using a new project, but that's fine. You can use it for your own. And all it does, it just, depending on the agent, depending on the shell, it downloads the latest release. Remember how I showed you that there's a bunch of different releases here in the repo, right? Like if I scroll here and I see Claude, Copilot, Cursor, and Gemini, and Shell and PS, it just, depending on your choices, is going to download the one that is the most relevant to the scenario, extract it, and that's it. That's all it does. That's the complexity of that CLI. But let's go to the actual folder. Let's go to SuperPod. And we're going to launch VS Code right from there. So we can actually see this in action, what this looks like. Oh, nice dark theme in VS Code. I'm a big fan of dark themes. We're going to look here, and as we saw in the zip files before, there's the two folders, right? There's the .github with prompts, and there's specify. So with prompts, because every slash command is represented by its own prompt file, we have plan, specify, and task, right? So if I open it, it has the details for what the command actually does. Specify just as well. We have tasks, and then for memory, we have the constitution, which is a concept that, shout out to John Lamb, my colleague, that actually bootstrapped this entire effort. Like, he created Specify. He's the one that actually built around the principles behind Spec-Driven Development. But the constitution embeds the non-negotiable principles for your project. So if you're in an organization that says, oh, we're building all the web apps with Next.js and the databases have to be Postgres hosted in AWS, you encode this here. This is an avenue for you to have this concept of opinionated stacks, right? So you can design different opinions about what your stack should be, and that stuff gets baked into Constitution. You can then share the Constitution within your org, within your team, with your colleagues in other divisions, right? Because it becomes this document that embeds the core principles that you have to follow to build a project. Now, because for a lot of the stuff, we're showing you how to build this with LLMs, with actually modern coding models, these constitutional principles that are embedded in this document become super important because it grounds the model into what pieces of your constraints it needs to respect at all times, regardless of the project class, right? So this is what the constitution is. And then we have some helper scripts here. We use PowerShell because it's on Windows, and I chose PowerShell for it. And we have some templates that we'll get to in a second. Now, before we get started, let's actually establish a constitution for our pod site. So I'm going to use AI. I'm going to use Claude Sonnet 4 to go in and write the constitution for me. I want to keep it short. I want to focus on just web apps, and I want to keep it generic. So I'm going to say, let's say, update the constitution based on a template. Pick 3 principles for web apps. Actually, it's a static web apps with Next.js. Because Next.js is the latest framework that I've been tinkering with, I'm just going to use that. So we'll see what it comes up with. Normally, you would write this by hand too. You don't actually need to ask AI to write this because you can just embed this context directly. It's just write the principles, just outline it, and you can do this based on just the assumptions that you have within your team or organization. So let's see what's going to happen here. It looks like it analyzed my project. It did not find any package.json, but okay. It actually embedded some content here, and we'll see what this content looks like once we actually complete the changes. We see some static first architecture. Yep, that makes sense. Component first. Yep. Build time optimization. I like this. Okay. Seems reasonable enough. That seems okay. There's some development standards for testing strategy, perf requirements, deployment workload, static export process. All right, cool. That sounds good. Let's keep this as is. So this constitution essentially establishes the non-negotiable parts. We have static first, component first, and build time optimization. Let's assume that is what we wanted. Now, I'm going to use the specify command, the specify, right? So I can do /specify to define my first step here, the PRD, the product requirements document. If you're a product manager, you know exactly what this is. If you're a product manager and you don't know what this is, you need to brush up on your product management skills. It's simple as that. So, but before we look at the specify command here in the actual chat box, let's look at what the command does behind the scenes. So I'm going to open the specify.prompt.md because this is Copilot, but the same would work for Claude, Gemini, or Cursor. We have the metadata, and there's some steps for the model to follow. First of all, it's going to run the script, the specify scripts PowerShell, right? The create new feature. That's going to bootstrap a new feature branch based on the work that I'm doing, and then output the metadata in the console as JSON. This is super important for context setting for us because as with any new feature, bug fix, change that you're driving through your code base, it's very rarely that you want to do it on your main branch. So specify, and by virtue of the templates that embeds in your project, it ensures that any new capability they're introducing with the help of the slash specify command is actually on its own branch, which is the logical thing to do. Then it also uses a built-in spec template, right? So we have the spec template here that outlines the execution flow for the template for the model to follow, some quick guidelines. And like I mentioned in my previous video, we focus on the what and the why of your product, feature, or bug fix. You're not really doing anything related to the technical stack. This is not the place where you go in and say, oh, like I want to use Next.js and I want to use this database and that database. Any good product requirements document is optimized, first of all, for somebody that looks at the feature, looks at the bug, and says, why is it the way that it is, right? And the first step, the slash specify, the building this PRD, is responsible for that particular aspect of the development process. So you're defining the what and the why, not the how. So there's also some additional information here, right? Like for AI generation, like some common practices. And then there is the template, things like user scenarios and testing. You kind of have to have those. Functional requirements. Also, for any product and spec, you have to have those. So it's there. And most importantly, there is a review and acceptance checklist. The spec itself is just one part of the puzzle, but you want to make sure that the LLM actually builds things according to the spec. So the spec itself is not enough. You have to verify that it builds it according to a set of standards. And we've established these here. Important call out here that I think got missed in a lot of the conversations around Spec Kit is that these templates that you see here for the spec, for the plan, for tasks, these are markdown files. You can customize them. If you look at these files and say, hey, like the project that I'm building does not require testing. My project is not requiring these, like the actual test framework and harnesses that the template outlines. Just strip them out. Just remove them. You don't need it. You can custom. These are markdown files. Add them, edit them, add them, remove them as you see fit. Just make sure that you correctly update all the configuration here that we have. So we have the specify command. So let's do that. So we were building Superpod. Just a reminder for folks listening to this, Superpod is our podcast landing page, right? This is what we are building right now. So I'm going to go ahead here and start tinkering with the specify command. So we're going to do specify. And then I'm going to type in some requirements. And also keep in mind, like the more concrete you get here with the requirements, the better. Like you're going to get better outputs if you're actually more specific. But in my context, I'm just going to say, look, specify, I am building a podcast website. Let's make this an interactive landing page. Recent episodes. We should have an episodes page that lists all episodes. And I also want every episode to have its own page. All right, this is, kind of specific. Let's say like the landing page. Actually, the site should be dark theme. Have a good modern gradient background, and current episode should have some kind of flashy animation on the landing page. Highlight it. Right? So I correct typos even when I type to AI, just so you know. So we have this prompt. Again, it's not super detailed, but we're going to use this as a starting point. So we're going to do this. And what's going to happen is this is going to execute the specify command, right? Based on the specify prompt. And it's also going to execute the script that we just saw. The script that is going to create a new feature. And the script itself is fairly basic, right? Like if I open a create new feature PS1, it's just a script that takes some parameters and then does some Git operations, right? Like if you see like Git checkout, branch name, it sets out the feature directory, it sets out the metadata, and then just outputs that metadata as JSON. That's all it does, right? So that's kind of it. But in the meantime, we take a look here at what's happening in the chat box. So it read the spec template as we requested from the prompt, right? Then it created the spec file. Then it made sure that it has a branch name, it has a spec.md. So we're going to keep the changes. I haven't checked it yet, but we have the primary user story, which is excellent. We have that. We have acceptance scenarios. We have edge cases. Okay. Yeah, perfect. We have feature, like the actual feature definitions through functional requirements. Great. They're numbered, key entities, and it actually has no items that need clarification. It actually did a one-shot assumption on a lot of the things that we can check here. And because you watching this, I hope, are human, you can look through this and see if anything stands out, if anything needs to be modified, or anything that needs to be tweaked, right? Like you don't have to take the AI's word on a very first step. If you see something here that you're like, yeah, that should not work this way that it does, go and change it. Go and modify it. It's a markdown file. Edit it. You can type. I believe in you. You can type the words on the keyboard. So we can edit this. And then, by the way, I can show you that this actually, if I type in git status here, right? Like we can scroll up and you'll see that I'm on a new branch. I'm on 001 Interactive Podcast Landing. And by the way, when Specify bootstraps a new project, it ensures that it actually works in a Git repo, not GitHub, Git repo. That is important because we want to make sure that you're always operating with this in a source controlled environment, right? So if you're building a new project, the Git repo is going to be bootstrapped for you. If it's an existing project, it's just going to use the existing Git configuration that you have there. So it's still going to create a new branch. It's still going to work. It's just going to be working slightly different because you might have your own branch configuration. So we've done the specify step. We have our spec that has all the components that we expected, right? Like we have the functional requirements, and it actually went through the checklist by itself, right? Because it passed the content quality. There's nothing that needs to be clarified. Great. This is a one-shot miracle. Next step here is for us to define the technical requirements. The technical requirements are done with the help of the /plan command. So you can, again, type in /plan. But before we do this, we have to look at what the plan actually does. So we have the plan prompt. And I can look here and I can see that I have to run another helper script that basically just outputs some of the metadata that we previously had. We have to read and analyze the feature spec. Okay, great. Read the constitution. Perfect. And this is what I mentioned earlier. Like we have the constitutional document. This ensures that it actually reads the constitution and embeds the principle of the constitution into the technical plan to ensure that the technical plan is meeting the criteria that your organization, or maybe you, established for the project. And then it's using the plan template to fill it out with different phases and then verify its execution, right? And the plan template is very, very basic. It outlines just like the spec template. It's exactly the same layout and structure, just like the spec template. You load the feature set, you fill technical context, right? Like it tells the AI what to do based on the context that you provide. The biggest value add of this entire SDD process is context management. Literally, that's what it is. Like people overthink spec-driven development as some kind of like magical thinking and everything else. All it is spec management. It is context management. It is ensuring that the LLM, the tooling that you have, has the right context at the right time. That's what it is. That's the magic of it. Now, we can look here. So we'll see that now we just have the spec document, right? Like this is just all we have. And as I mentioned, we were looking at the plan for the implementation. This is what the plan command. And there's a very neat piece here that outlines how specific technical constraints should be highlighted here, right? We have the language inversion, primary dependency, storage, so on and so forth. And again, because it's a markdown file, you might be working in an organization that has maybe different pieces. Maybe you want to put some different constraints or technical requirements. Also, include them here. Markdown file, easily changeable. This is going to be the repeated piece of this entire recording. These are all markdown files. You have the power to change them. Now, for the Constitution, we want to make sure that it fits the constitutional requirements. It's going to actually refer to the Constitution document. It has the structure for the source code and has some examples and phases in which the plan is going to be executed. It has to do some research, has to design the contracts, plan the task approach, and then some of the future implementation pieces. Now, I think we're ready to actually try to run the plan and see what happens. So plan, I will build this with Next.js and Shad Cyan. I decided to make my plan very, very basic. Now, can I make this a little bit more complex? Absolutely, I can. Do I want to in this demo? No. Now, it also ran the setup plan script. Great. We have the metadata here for the feature spec, the path to the implementation plan, specs directory, branch. Great. So this sets the context for the planning piece to actually have the information that it needs to go and run the actual execution of the plan. So let's allow it to go and copy the plan template, I guess, and then it embedded it here. We have our plan. It's going to start filling it out. And what I also noticed, by the way, is if you look at the work that I'm doing here, I'm using Claude Sonnet 4, but you have to experiment with different models. You have to try what the output of different models is because it can vary significantly. What I've also noticed is that sometimes, like if I use Sonnet 4, it can be very iterative, right? Like you see it filling out pieces of the document. It starts kind of one by one, section by section. GPT-5, for example, is going to be thinking a little bit and it's going to be spinning and spinning and spinning and then just spit out the entirety of the plan. So, potato, potato, you have to try it for yourself and see what works best. But the output can also be vastly different. Like I've noticed that Claude Sonnet 4 can be more creative with the things that it decides and determines for the project. It's going to fill out some of the gaps. GPT-5 is much more literal. It's going to listen to what you say and it's going to use those constraints, that and nothing else, unless you actually tell it to. So looks like it's embedding a bunch of information and structures, which is great. All right. It still has a bunch of stuff that it needs to fill out, so it might take some time. But the plan itself, critically, is the piece where you define the technical requirements. This is where you're no longer focusing on the what and the why, you're focusing on the how. This is where you decide the databases, the dependencies, the storage, the cloud provider. And this is also, again, because it's grounded in Constitution, you can use this as the jump off point for opinionated stacks, because you can essentially say your organization is using these constitutional constraints for the project, apply them to this technical implementation as well. Because if you do that, then any new project that you're building can be consistently built from the same basically set of requirements. And this is also an important point to call out here, is because the superpower of the specification is in the fact that you will be able to live in the multiverse of features. And what that means is because the specification itself is detached from the implementation. You're not writing code. The spec itself is essentially the artifact that you have. You can very easily use that to go and create multiple implementations depending on what you're trying to do. So if you're writing a CLI, you might think like, okay, well, like which one is more performant? If I write this in Rust or if I write this in Go? If you're writing a website, is it going to be the one working in Next.js better or the one using Astro? Well, guess what? Because the spec itself does not encode the actual implementation, you can use the same spec and have different plans. And then when you tie those together, all of a sudden, you have the exact same set of requirements, just implemented using different frameworks and different tech stacks, which is extremely, extremely helpful for experimentation and idea validation, because you're no longer constrained by one implementation. That was the problem. You build the code once, then somebody has to go in, and then you realize 75% in building that entire application that, if only we use this other framework, we would not have this and this and this other constraint that exists now because we locked ourselves into this technical choice. Because we were separating the specs and the technical plans and then the detailed tasks that need to be done around that, you retain the flexibility of actually pursuing the things that you want to pursue. And that is, I want to build 7 variants that use different designs. I want to build 10 variants that use different auth libraries. You can do this very, very easily with this approach. Now, let's check in here on what the agent is doing. So we have some work that's happening. It looks like it bootstrapped our plan. So we have our plan document that we're going to browse through in a second. It also bootstrapped the data model, which is important because it's also encoded in the template. We asked it to go and write the data model for us. So nice. It has some very podcast related data model information. It has some research. And because in this case, Copilot did not do research. I mentioned in the previous video, like Copilot doesn't yet do research unless you do something like use beast mode from Burke Holland. Shout out Burke. That is not going to happen here. So it's going to be researching things based on the training material here. So we have some research and technology decisions, alternatives considered, rationale, and so on and so forth. It's probably a reasonable set of choices here, but I would double check if I were you. But it did it. We have the artifacts for the planning stages. So we have the phases done. We're going to keep the files here. And also we have the contracts like component APIs, page interfaces. Great. Like it actually outlined pretty well what the architecture of the project should be. This is a technical architecture that is done here. We have the data model and so on and so forth. So the last piece here now is we need to break all of this down into tasks for the AI, right? And tasks for the AI is essentially a way for us to direct you to say, now you have the plan, now you have the spec. We want to break this down into consumable chunks that the AI itself can go and start executing one by one or in parallel where it's appropriate. So let's take a look here at the tasks view. So our task prompt. So I'm going to go to GitHub prompts and we have task prompt. And by the way, notice that it dynamically, as it was working on the plan, created a copilot instructions.md. So it's going to do the same thing for Claude, for Gemini, for any other agent. But it actually embedded some of the project knowledge into it that can be reused for this project down the line. So it's auto-generated, but using TypeScript, Next.js, Shad CN UI, React Tailwind CSS, Framer Motion for animations. Perfect. This is exactly what we wanted, and it tracks it all in Copilot instructions because we can then reuse it across the project. And now let's take a look at the tasks. So for tasks, we're once again running a check task prerequisites. It's going to just drop some metadata in a terminal for the task job for the agent to have the information about the feature, available docs, and so on and so forth. And then it's going to read some of the metadata, the files that we just saw created at the planning stage of technical architecture here. Very, very important. I keep clicking on these, but like you'll see them here in the specs folder. We have the contracts, we have the data model, quick start, research. All of these are referenced here in our task plan because this is what's going to be used for task computation. Then we use a task template. We're going to have setup task, test task, core task, integration, and polish, right? So important to note here is that you'll notice that there are certain things that are marked with a P. This means these are parallelizable tasks. It's important to notice to the agent that certain things can be done in parallel. Not everything needs to be done sequentially one by one. And some agents are very good about that. Shout out Cloud Code. It just works. So we have all these pieces here. And we have even a definition, right? Like include parallel execution examples and group them together. So we're going to use this and say tasks, break down the work we have into tasks, right? So like we have a lot of work here that we've looked at through the plan to the spec, and we're just going to say it, break it down into tasks. Give me a manageable set of chunks that the agent can go and tackle and address one by one. So it ran the script. It gets the metadata for the feature directory, for available docs that we have here. We have the research, the data model, we have the contracts folder, and the quick start. So it's going to go and ingest this context, right? I'm not going to say it actually like parse it. It ingests the context for his decision. And is going to use that context to then populate the task template into a dedicated tasks.md file. That file is going to be the sole source of truth for what the agent should be doing for this project. To me, I also noticed that if you make any changes to the spec or the plan, just use tasks to recreate the task. Don't do it manually. It's just so much more hassle. Just say /tasks, recreate the task based on the spec updates. Like it's just easier, and you're getting a much more robust, reliable task set. Now, I mentioned about the plan, and actually, like while the tasks are computing here, so let's take a look at the plan one more time. And one of the important pieces here that we have not actually looked at is the set of constitutional requirements. And the constitutional requirements are extremely, extremely important because we want to make sure that, like I said, that there's non-negotiables, right? So my project, I have static first architecture. It has a quality gate. It has a quality gate here embedded in the template that ensures that the constitution check must pass before you do anything else, before you start iterating on other things. These requirements must, so it's the constitution that we defined. It's static first approach, component first development, and build time optimization. Great, the constitution is there. And it looks like the tasks are created for us as well. So let's go to the task.md file. We're gonna keep it as is. And notice that there's these like checklisted tasks here. So I see the setup, I see critical, these tests must be written, must fail before any implementation. That makes sense to me. So we have a bunch of tests, we have core implementation, right? So we have our page implementation, we have all these details here, and static data and assets and all this stuff. So because these tasks are now broken down, I can use this as the jump off point to go and implement. And implementation here is very easy. You saw it in the previous video where I can just say implement, and that's it. This is what kickstarts this entire process. So I can just say implement the tasks, or the tasks if I could spell, but it would actually go ahead and implement these and start building the project. Thankfully, it understood the typo that I had here. But this is at its core what Spec Kit, Specify, and the templates are doing behind the scenes. I hope this was helpful for you to understand how this all works. Under the hood, you'll see that this is all just basically an experiment in us combining a bunch of helper things to assist you in bootstrapping spec-driven development projects, whether it's a brand new project, whether it's an existing project. And as always, we are looking for your feedback. If you have any thoughts on how this can be improved, any thoughts on maybe what's missing, what works, what doesn't, go to the GitHub repo. It's github.com/github/spec-kit. Add your issues, participate in discussions, open a pull request. Like, we're very, very much open to these conversations with you. We are excited to see this. We are so thankful to the community that's been engaging with us in helping craft this experience. We are at 18.5 thousand stars, I think. If I look correctly, let's take a look. Let's take a look at the screen. Let's wrap this video up on some positive news and see what's the volume. 18.6 thousand. Crazy. Thank you to all of you for watching this, for supporting Spec Kit and providing your feedback. We have a bunch of issues to go triage, a bunch of pull requests to triage as well. And of course, there's a bunch of discussions that we're catching up on. There is a lot of work that we are still going to be doing. So keep the feedback coming, and I'll make sure to keep you posted on any new changes, updates, and I'll see you on the next one.